So here we are, we're giving a quadratic function. Here is our function. We're asked about minimum or maximum. And then where does it occur? Remember, where does it? That's an x-coordinate. There we go. It's telling us it's the x-coordinate. And what is the function's minimum or maximum value? Again, they don't put it here, but that's going to be a y-coordinate. So one of the ways, you could just analytically say, okay, I know there's a positive in front of the x squared, right? That's a positive 1, so it's going to be positive gives you a smile, which means we're going to have a minimum. But I always encourage you also to go ahead and just graph it. Again, you don't have the Alex calculator here, right? They don't give that to you, but that's okay. We have, hopefully, you have your own handheld calculator where you can just enter it in. Oh, that's the wrong negative. It has to be a subtraction, right? Minus 6x, and then plus 13. We're going to graph this. I'm going to go to the zoom standard. And again, sometimes graphing, the hardest thing is getting the window just right, unless they've given it to us. Okay, we can see the minimum, and we can see it. It looks good. We don't have to resize our window to go up or down, so that's all good. We definitely see it's a minimum. So here's another way, right, of either validating it or seeing it's going to be a minimum, not a maximum. Where does it occur? Well, I'll do this in two ways. We can graphically just find the minimum. So we go to second, calc is one of our tools, and we can go down to number 3 to find that minimum. And to find the minimum, we need a left bound. Currently, we are on here, we're at x equals 0 and y equals 13, so we don't see anything. So let's walk our little spider to the right, and you see it coming down. You can down here see the coordinates where it's at, and that's why we can see it now. It's below 10. This is to the left of the minimum point. The minimum point is right here down at the bottom. So I'm going to hit enter. And then it's going to ask for a right bound. So we're going to take the little spider and walk it to the right. Go down to the valley, back up the other side. I like to go far. You can go just a little bit if you want, but you just have to be to the right of the minimum point. I just go further than I need to. And then we go for our guess. This is not our answer here, right? It's asking for a guess. We're going to hit enter. It's going to go back and forth between these two boundaries and find the minimum. It'll be so quick we won't even know what happened to us. Just like that. 2.99999. Let's round it to 3 and 4. So the x value is 3, the y value is 4. We've got our answers right here. That's going to be 3. This is going to be 4. Okay. Now, say you don't have a graphing calculator. How could you go about doing this? Well, the other thing you can hopefully remember that the minimum or maximum, whichever one, that these values occur at the vertex. And the vertex, again, thinking of the general form of quadratic is ax squared plus bx plus c, that the x-coordinate of the vertex is going to be minus b over 2a. It's not the quadratic formula, it's just part of it. And then the y-coordinate is going to be take that x-coordinate, minus b over 2a, and plug it back into the function. And we're going to see we get these same values, but I want you to see both of those. Again, if you're done, you're done, but here we go. So what is b? A is 1 in front of, because it's 1x squared. B is going to be negative 6. So the x-coordinate is minus negative 6 over 2 times 1, which is negative. Negative is a positive, 6 over 2, which is 3. That's exactly what the graph showed us. Then we take this 3 and we plug it into the function. So we need to find now g of 3. And so we take 3 and we're going to square it. Minus 6 times 3 plus 13. 3 squared is 9. Negative 6 times 3 is negative 18 plus 13. 9 and 13 is 22. 22 minus 18 is going to give us 4. That's what we got there. Okay, so 2 different ways to do it. It's good to verify and validate everything, but that's how you can do number 8.